Let's now evaluate this given integral. That is, we have to evaluate integral of sine inverse of x over 6x squared dx. So in step 1, we are going to utilize the integration by parts method. Integration by parts. First, I'm going to rewrite this given integral as like that. That is sine inverse of x divided by 6 squared dx. So this can be written as I write down this sine inverse of x as it is, and we have divided by 6x squared. So this could be written as 1 over 6x squared and then dx. So it's basically we have written this as a product of two different functions. The first function is an inverse trigonometric function, and then the second function is an algebraic function. So integration by parts method, if we have to follow this rule called ILATE, where I stands for inverse trigonometric functions, L stands for logarithmic, A stands for algebraic, and then T is for trigonometric, and E for exponential. So we have to see in this order, that is from left to right. So when we see left to right, the inverse function comes first. So basically we follow this rule to choose the U, and once we have chosen the U, rest of the parts will become the dv. So when we follow this rule, since I comes for, that is, we have to look out for inverse trigonometric function. Yes, we have a inverse trigonometric function, that is sine inverse of x. So which means we can choose u as, so we choose u as the sine inverse of x. And then rest of the terms, that is 1 over 6x squared dx, this is chosen as dv. So I'm going to write dv. This equals 1 over 6x squared dx. Now let's consider this as separately. Here we have to differentiate. So we differentiate this side. So differentiation of du is du, and differential of sine inverse of x is, when we use the standard formula, we will have 1 over under the root of 1 minus x squared, and then we put the dx as well. So basically we take differentials on both sides, but on this side we have to integrate so that we will get v. So when we integrate, put this integral symbol, integral of dv is just v, and then we have to integrate this 1 over 6x squared. So I can factor this 1 over 6 and then rewrite this 1 over x squared as x raised to the power of negative 2 dx. So this becomes, when we apply the power rule of integral, this becomes x raised to the power of negative 2 plus 1 divided by the same number, that is negative 2 plus 1. And this time we will not have to put the constant of integration, so just ignore that. We will put that when we use the integration by parts formula. So let's get this simplified. So this is equal to 1 over 6 x raised to the power of negative 1 over negative 1. So it's basically negative 1 over 6 times of x raised to the power of 1. We can rewrite this as 1 over x. So this is written simply as negative of 1 over 6x. So this is v. Now let's apply the integration by parts formula. So I'm going to rewrite this original integral, that is sine inverse of x times of 1 over 6x squared dx. As we considered this sine inverse of x as u, and then the remaining term, that is 1 over 6x squared as dv, we can apply the formula, that is integral of u dv, and this equals uv minus integral of v du. So let me transfer this formula just above this expression. So we will have it here. So therefore, when we apply this formula, so this equals, because this is in the form of u dv, which means we apply this formula. So according to the formula, we have to multiply u and v. We know that u is sine inverse of x. So I put sine inverse of x times of v. We found the v as negative 1 over 6x squared. So I multiply by negative 1 over 6x squared minus integral of v, that is negative 1 over 6x. I'm sorry, this is 6x, not 6x squared, times of du. So let's check du. So this is the du, that is 1 over under the root of 1 minus x squared dx. So I write down this as 1 over 1 minus x squared. This is under the root dx. So we will simplify this. So this is going to be, we have a negative 1 here. So I can rewrite this as negative of sine inverse of x. In fact, we can put a bracket over 6x, and then we have we have to multiply the negatives. That is, we have negative times of negative is positive, and I can factor this 1 over 6 and then put only the terms with x. So therefore it is the integral of 1 over x times of under the root of 1 minus x squared dx. Now we put this integration constant c. So for the integral of this expression is negative sine inverse of x over 6x plus 1 over 6, and then integral of 1 over x under the root of 1 minus x squared dx plus the integral constant c. So this completes our step 1, and in step 2 we are going to focus on this integral alone. That is, we have to integrate this expression. So let's proceed to step 2. That is, let's consider this integral separately. That is, we have to integrate 1 over x times of 1 minus x squared under the root dx. Maybe we call this equation as 1. Once we determine the integral of this one, we come back here and replace this integral as we have found the result of this integral. So let's call this integral as 1. This we call this equation as equation 1. Now let's focus on this, and let's see how to determine this integral. Here I'm going to solve this integral by method of substitution. That is, I'm going to put u equals under the root of 1 minus x squared. Now I have to take the differentials on both sides. In fact, I can consider this as 1 minus x squared. I put this in exponent form as power 1 by 2. Now if I take the differentials on both sides, I will get du equals, I apply the power rule here. That is, I put the power in front, and then 1 minus x squared raised to the power of 1 by 2 minus 1. So this becomes 1 by 2 minus this is 2 by 2. So it's basically 1 minus 2 is negative 1 by 2. So I put this power as negative 1 by 2. And then we have to apply the chain rule to differentiate the 1 minus x squared. So differentiation of 1 minus x squared is, that is, we have to differentiate 1, which is 0, and then differentiation of x squared is 2x. So basically we will get only 2x. So we have to multiply by the term negative 2x. We now see that we can cancel this 2 with this 2, and we then have this negative x. And this could, and I forgot to put this dx, so let me put this dx. So therefore du, this equals, I put this as negative x. So this is negative x over, we can rewrite this 1 minus x squared raised to the power of negative 1 by 2 as a power of positive 1 by 2, which equals under the root of this expression. So I write down this as 1 minus x squared root and then dx. So we have found the expression for du, as well as we know the substitution which we made is under the root of 1 minus x squared equals u. So we can rewrite this integral after the substitution as, let me first copy that. That is, we have 1 over x times of 1 minus of x squared under the root dx. This is integral of, so this equals, we can solve for dx from this one. So if I solve for dx from this one, I basically have to multiply by this term and divide by this term, or else I have to multiply by the reciprocal of this term. So I put negative of 1 minus of x squared under the root over x times of du. So this is the expression for dx, so which I'm going to replace it over here. So therefore this becomes integral of negative of 1 minus of x squared over x and then du, and we have just replaced for dx, so we will replace for x as well as this under the root of 1 minus x squared. Now getting back to our substitution, that is we made the substitution u equals 1 minus of x squared under the root. Let's square both sides, so we get u squared equals 1 minus x squared, and this means we can determine x squared. So x squared equals 1 minus of u squared. So so far we have converted this dx into this expression. We have x as well as under the root of 1 minus x squared. So I'm going to put this as multiplied. Maybe I put this as multiplied by 1 over x, and this expression under the root of 1 minus x squared is basically u. So I put this as u. Let's see how to convert all these things in terms of u alone. As you can see, this expression 1 over, I'm sorry, under the root of 1 minus x squared, this can be replaced as u. So I'm going to rewrite this integral as negative of u du over x, and then we have 1 over x times of u. We see that we can cancel this u with this u, so therefore these two gets cancelled, and finally we have only this x times of x, which is x squared. We replace x squared as 1 minus u squared, so therefore this integral gets changed to, we already have a negative, so I can factor out the negative, and then du over x squared, which is 1 minus of u squared, which means we have converted this integral in terms of u variable alone. So we can just integrate this. Let's say this is equation 2. So basically this is the integral of this one. We have not yet completed, so we have to integrate this. So I'm going to integrate this using the partial fraction method. So first I rewrite this integral as negative of 1 over 1 minus u squared du, and let's decompose this into partial fraction. So therefore I can write down this 1 minus of u squared. This could be written as by applying the difference of square, we can write down this as 1 plus u times of 1 minus u. And when we decompose this into partial fractions, we write down this as a over 1 plus u plus b over the next term, that is 1 minus u. Now let's focus only this equation, that is this part. So here I multiply both terms or all the terms by this common denominator. So when I do that, I will get only 1 on the left side, and a will get multiplied with the term which it doesn't have in the new denominator. So which it does have in the denominator. So in the denominator we have 1 plus u. When we compare this with the common denominator 1 plus u times of 1 minus u, we don't have this 1 minus u term. So a will get multiplied with that term only, plus b times of, for the denominator of b we have 1 minus u, and for the least common denominator which is 1 plus u times of 1 minus u, we don't have this 1 plus u, so b gets multiplied only with 1 plus u. Now we can easily solve this constant a and b by letting u equal to some random value. So first I let u equal to 1. So therefore this becomes 1 equal. If we let u equal to 1, this becomes 1 minus 1 plus b times of 1 plus 1. So 1 minus 1 is 0, so a this terms become 0, and this 1 plus 1 is 2, so this is basically 2b. So that is 1 equals 2b, and this implies b equals half. Now let me let u equal to negative 1 into this equation. So I get 1 equal a times of 1 minus of minus 1. So basically this is 1 plus 1, which is 2. So I replace this as 2 plus b times of 1 minus of 1. So basically b becomes 0. So we can solve for a from this, that is 2a equals 1. So a equals half. So now we have to determine the values of a and b, which is found to be half. Both of them are found to be half, which means we can go back to our partial fraction decomposition and replace this expression, that is 1 over 1 minus u squared. So basically this equals we return this as 1 plus u times of 1 minus u. So now we, after partial fraction decomposition, we have written this as a over 1 plus u, that is 1 by 2 over 1 plus u. So therefore this gets multiplied like this, plus b over 1 minus u. So I replace the value of b, so therefore this becomes 1 over 2 times of 1 minus u. So this is the partial fraction decomposition of this expression. So which means this expression is equivalent to this expression. So we can go back to our equation 2 and get this replaced. So therefore the expression, that is when we go back to a step 2, we started off with this integral. So I'm going to put that on the left side. That is the integral of 1 over x times of 1 minus x squared under the root dx. This equals, the equation 2 is a negative of 1 over 1 minus u squared du. Now let's replace this expression 1 over 1 minus u squared as like this. So therefore this becomes negative of 1 over 2 times of 1 plus u plus 1 over 2 times of 1 minus u, and then du. So now we can easily integrate this. So therefore this becomes, we can integrate this separately as well as we integrate this separately. So I just keep this negative as it is, and when we integrate this 1 over 1 plus u is basically natural logarithm of the expression. So I write down this as natural logarithm of 1 plus u, and then for the second term I put this 1 by 2, and once again here also it is natural logarithm of 1 minus u. However, this term we have to multiply it by the derivative of 1 minus u when we apply the chain rule. So the derivative of this is negative 1, so which means this expression will get multiplied by negative 1, or else we can change this positive to negative. Let me do that. So this term basically becomes negative, and I can also erase this. Now using the properties of logarithms, we can combine these two terms. That is we have the common factor 1 by 2, and so therefore this becomes, we will have negative here. So when we factor out the half, we will have natural logarithm of 1 plus u minus natural logarithm of 1 minus u, and this is absolute value. Now we see that we have natural logarithm of some expression minus natural logarithm of other expression. So use the properties, that is a difference property of natural logarithm, that is natural logarithm of a minus natural logarithm of b. This equals natural logarithm of a over b. When we use this property, we can rewrite this as, we have this negative 1 by 2 natural logarithm of 1 plus u over 1 minus u, and then this absolute value. So we get like this, and we can substitute the value of u in terms of x and write this expression in terms of x. So here I have copied only the equation 1 as well as the expression for u. So first let's convert this into x expression involving x. We just have to replace the u as under the root of 1 minus x squared. So therefore this becomes negative 1 by 2 times of natural logarithm of 1 plus u is replaced as under the root of 1 minus x squared over 1 minus u, which is 1 minus x squared under the root. And this is absolute value. So we have determined this integral, that is 1 over x times of under the root of 1 minus x squared dx equals this expression, which means we can replace it over here. So therefore our original integral will become, that is sine inverse of x over 6x squared dx. So this equals, we write the first term, that is negative sine inverse of x over 6x, and when we replace this expression as this one, we have the factor negative 1 by 2. So negative 1 by 2 times 1 by 6, 1 by 6 times of negative 1 by 2, this equals negative 1 by 2. So I'm going to replace negative 1 by 2 times of this natural logarithm expression, that is natural logarithm of 1 plus 1 minus x squared under the root over 1 minus of x squared under the root. This is in absolute value plus the integral constant c. So this is the final result of the given integral.